Dark matter. A mysterious force that holds galaxies together. It's invisible and undetectable, so you can imagine its existence would be hard to explain. It was first theorized in the 1930s by Jan Oort and Fritz Zwicky. But for decades, the astronomical community didn't take it seriously. After all, the idea that an unseeable mass must be present to create enough gravity to hold fast-moving galaxies together sounded a bit far-fetched. But actually, they were right. And the theory was substantiated by a woman. Her name was Vera Rubin. She observed, she did the math, she mapped how galaxies actually moved. Today, she's considered one of the most important astronomers and astrophysicists in history. But during her lifetime, she and her ideas were met with skepticism, dismissals, closed doors. Several of her then rejected findings are now widely accepted as fact. Listen up, class. Here's how Vera Rubin's relentless pursuit of knowledge actually changed our understanding of the universe. Let's rewind. Vera Rubin was born in Philadelphia in 1928. When she was 10 years old, her family moved to Washington, D.C., where she built her first telescope with the help of her father, using cardboard tubes and old lenses. By 12, she preferred stargazing over sleeping, mapping the stars and watching meteor showers from her bedroom window. Her father was an electrical engineer and amateur astronomer himself, and supported her curiosity. Yet, as Vera later recalled in interviews, there were no female astronomers for her to look up to. But she knew astronomy was her calling. When it came time to go to college, most university astronomy departments simply didn't admit women. But Vassar College was an exception. That's where she earned her undergraduate degree, and she was the only astronomy student in the entire program. She went on to get her master's at Cornell in 1951. Her master's thesis challenged the accepted Big Bang theory by proposing galaxies weren't just expanding. They were rotating around an unknown center. And the response? A polite, unanimous rejection from the American Astronomical Society. Of course, her little theory is now accepted as fact. Vera also discovered the supergalactic plane, a structure that connects galaxies like an intergalactic equator. But since the AAS was busy ignoring her thesis, this discovery went uncredited until later, when it was attributed to a different male astronomer who independently discovered it years later. While completing her PhD at Georgetown University, Vera discovered that galaxies were not randomly distributed in the universe, but instead had a tendency to actually cluster together, suggesting for the first time the presence of large-scale cosmic structures. She was right, but of course the scientific community ignored this too. You'd think after so many discoveries, before she even completed her PhD, that Vera had an easy time at school. But she, nor any female students at Georgetown, were even allowed to go inside the academic offices. So, she would meet her thesis advisor in the lobby. Vera's big break came when she joined the Carnegie Institution's Department of Terrestrial Magnetism. There, she met Kent Ford, who had built an advanced spectrometer, a tool used to observe distant space. Together, Vera and Kent started observing stars with unprecedented precision. The focus of her research was galactic dynamics. That's how stars move in galaxies. Up until this point, Conventional wisdom said stars closer to a galaxy's center, where matter is denser, should move faster than those on the outskirts. Think of our solar system. Mercury zips around the sun faster than, say, Saturn because of the laws of gravity. But when Vera observed the Andromeda galaxy, the closest galactic neighbor to our galaxy, the Milky Way, she noticed something off. The stars on the outer edges of the Andromeda galaxy were moving just as fast as those in the center. According to gravity, with the outer stars orbiting at such a speed, the galaxy should have flown apart. But it didn't. Vera realized there had to be something else, a missing mass, an invisible substance holding everything together. This wasn't a brand new idea. The existence of dark matter had been hypothesized decades earlier by Jan Oort and Fritz Zwicky. But Vera now had the data to prove it. Her discovery was revolutionary. By proving the existence of dark matter, Vera fundamentally changed our understanding of the universe's structure. She showed that the gravitational pull needed to hold galaxies together couldn't be explained by visible matter alone. There was something unseen, accounting for the majority of the universe's mass. Before Vera, scientists thought what we can see or detect, solids, liquid, and gas, was what the universe was made of. But when Vera discovered dark matter, she realized atomic matter is only 5% of what exists. The other 95? Invisible, undetectable, and until Vera, an idea considered completely impossible. Discovering dark matter was a foundation upon which scientists later built theories of dark energy, expanding our concept of the universe to something far larger and more complex than anyone had imagined. Kent, her research partner, himself once said, quote, "I build the instruments and she did the science," crediting Vera as the true driving force behind the discovery. In interviews, Vera often reflected on the isolation she felt as a woman in astronomy. Despite Kent's respect and support, Vera faced constant challenges and dismissals from her male colleagues. In meetings, she was interrupted, ignored. In 1965, Vera became the first woman allowed to use the telescopes at Palomar Observatory in San Diego, California. Women were largely barred from observing at major observatories until Vera broke the glass ceiling. At Palomar, there wasn't even a women's restroom. She famously fixed this problem by cutting a piece of paper into a triangle and taping it on like a skirt to the men's restroom sign. Dark matter finally explained the unexplainable, why galaxies didn't disintegrate. And this discovery? It turned the field of astronomy and physics on its head. But even with this groundbreaking work, Vera didn't get a Nobel Prize. Instead, 44 years later, a Nobel Prize was given to a group of male astronomers, the discoverers of dark energy, an expansion of her work, whose work, unlike many of Vera's findings, was taken seriously when they presented it. Vera's contributions went far beyond the discovery of dark matter. She fought for women's rights in science, helping open doors at observatories and institutions for future generations of female astronomers. So next time you look up at the night sky, remember Vera Rubin. She didn't just observe the universe, she uncovered its hidden truths. Most of what's out there is invisible, undetectable, and was once thought impossible, until Vera pointed her telescope to the sky. Thank you, Vera, for revealing the unseen and helping us understand our universe and beyond. Here at Actually History, we're seeing history through a new lens and giving credit where it's actually due. Most of our stories are based on this book, and she co-wrote it. This is, to her credit, Historic Achievements and the Women Who Actually Made Them Happen by Caitlin Colmo and Emily McDermott. We kindly ask, if you're interested in our mission, hit like, subscribe, and stick around. More stories to come. Class is in session.